Good morning. Today we're going to look at section 5E, which is Spearman's rank correlation coefficient. The purpose of Spearman's rank is when we do a scatter plot and our scatter plot itself does not have, when we plot the points, it does not have a linear fashion. So it's not going, the points aren't going in a general linear direction. So for example, if you look at this problem here, this is comparing track and field athletes and their maximum speed with their longest jump. And so I've plotted those points and you can see it on that graph there. And if you look at that graph, notice that the points kind of go, they start to go up like that. And because of that, that's not necessarily a linear fashion. Linear fashion means all the points are just kind of going in a general straight direction, and these are not. So when we run Pearson's correlation coefficient, like we did on section 5D, run your lin-reg when you plug this into your L1 and your L2 on your calculator and you do that stat and scroll over to calc and do number 4 lin-reg, you end up getting 0.864, which is showing that it's got somewhat of a moderate to strong positive correlation. But when it doesn't have that linear fashion, we have to then look at Spearman's rank. So how do we do that? Well, what we do is we take these numbers that are in our table and we rank them. We put number 1 on the smallest number 2 on the next smallest, and continue that. So if you look, I have done that with this table here. So for example, you can see that 7.28 is the smallest x value, or the smallest speed, I should say. So that's why I labeled that as a 1. And then the next smallest is 7.46, so that gets to be a 2. And I go through and do that with all of the numbers in the x and the y. And then I end up with these new values here. So these values become different ordered pairs. Instead of the A point, or the A athlete, being 8.68, 4.64, now it is 6.8. And then the next one would be 9, 10, etc., etc. So what you do is you go to your calculator and you plug those values that I've highlighted in for your L1, like this is your L1 and your L2, and you rerun your Pearson correlation. And when you do that, you can see this is our new graph when you plot those, and that ends up looking a little bit more linear. And when it's a linear fashion, then your calculator is going to run that correlation a little bit more accurately. So when we run this, we will find that our R value is about 0.952, which is actually a strong positive correlation. But what we have to remember is that it is a strong positive, but it's not necessarily linear. And that's the big key there, is this Spearman's rank. By doing Spearman's rank, it's giving us a little bit more accurate correlation, but we have to remember that that's not necessarily linear. So let's talk about one more little thing before we do a problem together. So when you have a table of values and x and y they end up having a same number show up more than one time, which happens a lot when you do scatter plots, they're called ties. And when you have a tie, what you end up doing is you end up finding the average of those ranks. So if you look at this, so our 7s are a tie in that y. So when we go to rank it, 1 is our first rank, 3 is our second rank, and then the third rank is 4, the fourth rank is our 6, and then 7 would be our 7s would be the rank of 5 and 6. So what you do is you find the average of 5 and 6. So 5 plus 6, 5 plus 6 divided by 2, and that's where that 5.5 is coming from. And so you just give both of those a 5.5 rank, and then you move, since we've used 5 and 6, our next ranking would be number 7. So that's why the 8 is a rank of 7. So let's look at our example here. So we have 10 students in a typing contest, and they're given a minute to type as many words as possible. And we identify how many words that they typed and how many errors they had. So I'm going to go to Desmos and let's It's saying to calculate R sub P and R sub S. So R sub P, this is our Pearson correlation. So this is before the ranking. And then this one is our Spearman. So this is what we get after we rank them and use the ranks. So that's the difference between those two right there. And it's asking us to calculate both of them. So let's go to our Desmos and let's plot those points here. Okay, so we want to add a table in here. And our number of words is our X. So we have 40, and then 53, 20, 65, 55. Actually, that's not 55, that's a 35. Oops. 35, 60, 85, 40, 35, and 76. Those are our X values. And then our Y values, our number of errors that we had, 11, 15, 2, 20, 1, 22, 30, 16, 27, and 25. And so here is our scatter plot. And let's run and calculate our R sub P. So if you guys remember on Desmos, you can go Y sub 1, so just Y1, and it'll automatically sub it for you. And then we have our tilde, so it's roughly, and then M, and then X sub 1 plus your B. And if you can see there, it's giving us an R value of 0.7438. So there is our R value. So let me write that down back on our slide there. So our Pearson, we found it to be 0.7438. So there's our Pearson. So now what we want to do is we want to go with this table and we want to rank our table. So let's look at our X's. Our smallest number in the X category is 20. So that's going to be a number 1. Our next one is 35, but notice we have 2 of them. So that's really the second and the third. So when I do 2 plus 3 divided by 2, that gives me 2.5. So this is both going to be, or these are both going to be 2.5. So that's the second and the third. The fourth highest is 40, or 49, excuse me. So that's going to be a 4. And then our 5, 53 is our, oh, hold on. I missed 40. So this should be, that's 2, 3, this is 4, this is 5, 6, and then we have 7, 8, 9, and 10. Okay, so there's our ordering, our ranking of the X's, and now let's rank our Y's. So this is 1. And then we have 2 is our 2, and then 11 is our 3rd, 15 is our 4th, 16 is our 5th, 20 is our 6th, 22 is 7, 25 is 8, 27 is 9, and 30 is 10. So what I'm going to do is I'm going to go back to our our table here, and we're going to redo our table in Desmos and plot those points. So let's get rid of these and let's start fresh. Okay, so we have the ordered pair 4, 3. So let's see here. This is 4. And then we had 6, 1, 8, 2.5, 7, 10. Let's see here. 5. Oops, that's not a 5. That's 4. 5, 2.5, and 9. And then our next one we had 3, 4, 2, 6, 1, 7, 10, 5, 9, 8. Okay, and if we zoom in here, so notice that that particular scatter diagram is much more linear fashion. So if we run again our linreg here, which if you were doing it on the calculator, once you have your L1 and L2, you would go to Stat, scroll over to Calc, and do number 4 linreg. So we have Y1 is about mx1 plus b. And there is our Spearman's rank, so 0.6626. So, whoops, not that one. 0.6626. So it's actually not as strong as it originally appeared to be. Now, part B is asking us to draw the scatter diagram and identify that outlier. So you can see when we look at our scatter diagram that this point, it looks like that 3.5 or 2.5, 9, that second to last point, that is the point that is kind of far away from everything else. So that would be considered our outlier, which is the original point of 35, 27. So if we look at our original points here, it's really this point right here that is our outlier. So then it's asking us to, recalculate without the outlier. So if I would take that outlier out and I recalculate this, it's going to drastically change what happens here. So I'm just going to delete this and I'm going to delete this one. Oops, went too far. And notice, you guys, when I took that 1 point out, look at that R value. It's 0.9395. And this is our Spearman, so this is our R sub S, whoops, but 0.9395. That's drastically different than what it was before. So look at how much that outlier is affecting it. Now if I were to retype in our original one, I would get, let's see here, let's just retype that because I deleted it. Okay, I need to add in a table. I shouldn't have deleted this, sorry. So we have 40, 53, 20, 65, 55, 60, 85. Okay, those are our X's, and then our Y's, we have 11, 15. Oh wait, I need to take out my outlier though. So I need to delete this one. 2, 20, 4, 22, 30, 16, and 25. Okay, so if I move, there's our original one. And then let's do our Y1 and run our linreg. Mx1 plus B. Oh, you know what? This is Y2. I forgot. And okay, so our value of our original is 0.9763. So if we go back here, this right here is 0.9763. So both of them showing very strong correlations without that outlier. So then the last question says, which correlation is more affected by the presence of the outlier? And very obvious, it was a much bigger jump from our Spearman's of 0.66 to the 0.939. So our answer here would be our Spearman's that is affected a lot more than the Pearson's, which is our R sub